Today our algorithm topic is quicksort. It is another example of divide and conquer rule. You know divide and conquer rule what is? It is dividing an array into two subparts and sort easily with the subparts sorting. Now what we have to do for quicksort? We can divide the array into two halves using a pivot, and we can select a left half, and then we can sort the right half. Okay, let we consider a array here 5 to 6 1 4 etc, and we have to arrange these elements in ascending order using quicksort algorithm. Here we can see the array 5 to 6 1 3 4, and the array index number is 0 1 2 3 4 5. Let we consider the first index number is the pivot, and the leftmost element we select as left, and the rightmost element we select as right. Now we have to see that the pivot value and the right and left value. Here the leftmost element is the pivot, and rightmost element value is 4. Here pivot value is 5 and rightmost element value is 4. If the pivot value is greater than the rightmost element, then rightmost element and pivot will swap their position, and if the pivot value is less than the left, then the pivot value swap with the leftmost element. Okay, here the pivot value 5 and the rightmost element value 4. So we have to move rightmost element towards the pivot. Okay, now we swap the pivot with the rightmost element, and now the new pivot is on the right side, and this is 5. Okay, here we can see the pivot value is 5 and leftmost element value is 4. We need to see that whether the pivot value is greater than the leftmost element. If pivot value is greater than the leftmost element, then need to change the index number of left. Okay, here 5 is greater than 4, so the left index will increase one position. Okay, here the left number is on 2 position. Okay, and pivot value is 5. Here 2 is lesser than the 5, so the left position will increase in another index. So the left position will indicate the number 2 array, and the number 2 index array value is 6. Now we have to see the pivot value is greater than the 6 or not. Here we can see the pivot value 5 is lesser than the 6, so we have to swap the value of pivot and leftmost value. Here we can see the pivot value is lesser than the rightmost element, so the right index will decrease one position, and it will indicate the number 4 index, which value is 3. Okay, now the pivot value 5 is greater than the 3, and every time if the rightmost value is lesser than the pivot, then we have to swap the position of rightmost value with the pivot. Okay, we swap this with 5 and 3. Okay, now the pivot value 5 is greater than the leftmost element, so the leftmost element index will increase to the index 3, and it will indicate the value 1. Okay, again we can see the 1 is lesser than 5, so it will increase its left number position and towards the 5, and now the pivot and rightmost and leftmost element overlap each other, so I found a sorted element 5. Okay, in the left side on the sorted element it is an array, and in the right side of the sorted element it is another array. Okay, now we have to sort first the left subarray and next the right subarray. Okay, with the same process we have to sort the left subarray. Okay, Then we again consider first element as the pivot, then the leftmost element as the left, and rightmost element indicates the right. And in the same process, pivot is greater than the rightmost element, so it will swap. Okay. And another time the pivot is greater than the leftmost element, so the leftmost element increase its index. Okay. On the same process, the leftmost element overlaps with the right number. Okay, so the number 4 value is sorted. Again, one is again we can take one as the as a pivot, and with the same process, one will sort, and in the same process whole array itself. When the left sub array is completed sorting, then we have to sort the right sub array. Actually here only one element left, so it will easily we can say it will be sorted as it is the it is greater than 5. Okay. Now we can see the sorted array. Actually it is a process of recursive algorithm. You may see recursion process in programming. This is use the same process to sort this array in quicksort algorithm. We have to find a pivot which divides the array into two halves, and with the help of this pivot we can ultimately find a sorted array.
We can see here the pseudo code. We take a leftmost number as a start point and rightmost number as the end point, and pivot index as the leftmost number. When the pivot index is lesser than the rightmost element number, and pivot index not equal to the rightmost element, not equal to the value of rightmost element, then we have to decrease the index of rightmost element. Okay. Then if the pivot number is greater than the rightmost pivot number is greater than the rightmost element number, then we have to exchange the index number of rightmost element and pivot index, and for the the reverse process for the leftmost element with the pivot number. Okay.
Thank you all. Have a nice day.